Imagine pushing your brain to its absolute limit. You are sitting for a grueling exam or attempting to solve a high-stakes problem that could dictate the entire course of your career. You are burning through your mental reserves, operating at max capacity. Then, the task ends. You are utterly depleted. Someone walks up and makes a mildly annoying comment, and your control snaps. You instantly explode with rage, break down into tears, or feel the urge to hide. Society traditionally views this reaction as a weak nervous system. This labeling frames the breakdown as a personality flaw, an embarrassing lack of willpower or emotional maturity. This explosive response actually stems from a purely mechanical, microscopic electrical glitch happening deep inside the brain's hardware. Reframing a weak nervous system as a physical chain reaction allows us to move past judgment and begin learning how to actually control the mechanism. At the cellular level, a weak nervous system is defined by baseline hyperexcitability. The microscopic architecture of the brain is essentially set to a hair trigger. The issue lies in the cell membrane. Specific gateways called ion channels are structurally too permeable, allowing sodium atoms to leak inside the neuron with almost no resistance. As that sodium rapidly builds up, the cell eventually trips its own wire. It fires off an alarm signal all by itself, self-exciting even when there is no valid reason to do so in the outside world. This structural sensitivity often begins at birth, either as a congenital trait or the result of physical trauma like perinatal hypoxia, a brief lack of oxygen during delivery. To make matters worse, special fast-track connections called electrical synapses can bypass standard chemical pathways, broadcasting this false alarm across the brain at lightning speed. These hardwired cellular leaks guarantee that the brain will overreact to minimal stimuli. Physical outbursts become an inevitable mechanical response rather than a conscious choice. Managing these hyperexcitable neurons requires a massive, continuous supply of biological energy and nutrients to keep the electrical balance in check. Heavy cognitive lifting, physical exhaustion, or a simple lack of vitamins and nutrients rapidly drain this energy reservoir. When the brain's energy is depleted, it loses the power to apply its inhibitory brakes. The system can no longer hold back the current flowing through those leaky sodium channels. This loss of inhibition leads directly to the chaotic behaviors we see during a crash: uncontrollable tics, hysteria, or sudden aggression. A nervous system breakdown represents a biological alarm system that has run out of fuel, operating without the safety mechanisms required to keep it stable. These leaky sodium channels essentially force the brain to operate using an outdated survival logic. The hyperexcitable hardware is trapped in a modern environment that no longer matches its primitive programming. For our primate ancestors, social conflict carried lethal stakes. Among chimpanzees, a sharp word or a direct challenge to the hierarchy frequently results in a violent physical struggle for life. This survival logic remained relevant throughout most of human history. Even in the last century, angering an authority figure like Stalin meant risking immediate execution. In the 21st century, the vast majority of our daily stresses are non-lethal. A failing grade, a tough day at the office, or an awkward conversation cannot actually kill you. However, your hyperexcitable neurons cannot distinguish between an awkward conversation and a physical predator. The leaky channels fire the same life or death alarm for both. Modern anxiety occurs when an ancient survival mechanism misinterprets minor social friction as a direct threat to your existence. Since we cannot physically reach into the brain to rewire the sodium channels, we must focus on managing the inputs that trigger them. The first line of defense involves strict resource management, addressing nutritional deficits and seeking psychiatric support when the system requires chemical stabilization. Environmental control provides the second line of defense. If a specific setting, like a toxic job, constantly drains your metabolic energy, the only biological solution is to physically leave that environment. Cognitive reframing offers the most accessible tool for long-term stability: the conscious practice of de-escalating the perceived stakes of everyday conflicts. Realizing that a social slight will not kill you starves the hyperexcitable neurons of the panic signals they need to fire. You are essentially teaching the alarm system to stay quiet. Mastery over this sensitive biological instrument comes from changing its fuel, its environment, and its perception of danger.